In this lesson, we're going to look at properties of logarithms. We're going to use them primarily in our next few lessons for solving logarithmic equations. Remember that a logarithm, base A, of x equals y is the same thing as saying that a to the y power equals x. So a logarithm, the whole thing, is actually an exponent. So it might be helpful to review our exponent rules for a minute. Remember, if we have x squared times x cubed, that's going to equal x to the 5th power. And what we did was we added our exponents, 2 plus 3, to equal 5. If we have division, x to the 5th divided by x cubed, that's going to be 5 minus 3, which is 2. So subtraction of the exponents works when we're dividing. And we're going to see that those rules follow when we're working with logarithms. But before we get to that, let's review some of the things that we already know about logarithms. If we have that the logarithm, and this is going to be always for a is positive and not equal to 0. We're going to have the logarithm base a of a equals the logarithm base a of 1 equals, and the logarithm base a of a to the r power equals. And what I want you to do is pause the video for a minute, think about rewriting each of these, or think of each of these as an exponential statement, and then you'll be able to evaluate what they're equal to. For instance, I'll do the first one. A to what power equals a? A to the first power equals a, so this is equal to 1. You go ahead and do the next two. Pause the video, do the next two, and then turn the video back on. So we see on this one that a to what power equals 1? A to the 0 power equals 1. And then this last one, a to what power equals a to the r power? And that one is r. I'm also going to write each of these rules for a specific logarithm. Here, we're just using our generic a. This could be the logarithm base 2 of 2 equals 1, or the logarithm base 7 of 7 equals 1, etc. But we're going to be using, when we're solving logarithms and we're actually using logarithms, we're going to see that the natural logarithm is going to be a very commonly used one. So we're going to write the specific base e, because remember the natural logarithm of x is the same thing as the logarithm base e of x. So we're going to write each of these three properties on the left here in terms of logarithm base e using the natural logarithm. And I'm going to do the first one. So if we're looking at the logarithm base a, but in this case specifically logarithm base e of e, that's the same thing as saying the logarithm base e of e, and we'll know that that is 1, because e to what power? E to the first power equals e. So I'd like you to rewrite these other two statements using the natural logarithm. In other words, using base e. So see if you can write the statements here and here in terms of a natural logarithm. Pause the video and then turn it back on when you're done. And we're going to see that this one is the natural logarithm. That's the logarithm base e of 1 equals 0. And the natural logarithm base e of e to the r power is equal to r. And what we're training ourselves to do here is we're training our brains to understand what these symbols mean, what I mean when I say ln1. I have to understand that that means the logarithm base e of 1, which in turn means e to what power equals 1. So it's going to take some practice to train our brains to understand, to read these symbols and understand what they mean. All right, let's think back what we saw up here with addition of exponents for multiplication and subtraction of exponents for division. If I have a logarithm base a of n times m, that's going to turn out to be the same thing as the logarithm base a of n plus another logarithm base a of m. So n times m becomes addition of two separate logarithms. I'd like for you to see if you can rewrite what this one would be equal to. Pause the video for a second and rewrite this one. And we see that this one, because we have division, is the logarithm base a of n minus the logarithm base a of m. And we can go either way here. If we have the sum of two logarithms, we could rewrite it as a single logarithm with multiplication. Or if we have a logarithm of two things multiplied, we can break it apart into two separate logarithms. And we're going to practice doing that in our next lesson. Then we have a third rule here, a third principle here. If we have the logarithm base a of n to the m power, you know what, let's go ahead and change that. Let's go ahead and use logarithm base a of n to the r power. N to the r power is n times itself, r times. So let's say we have n to the fourth power. That would be n times itself 4 times. If we rewrote that as a sum, we would have the logarithm base a of n plus the logarithm base a of n 4 times using our rule here. The repeated multiplication became repeated addition. So if I have the logarithm base a of n added to itself 4 times, that becomes 4 times the logarithm base a of n. So what we see here is that if I had the logarithm base a of n to the 4th power, that's the same thing as logarithm base a of n times itself 4 times, my exponent here became multiplication in front, because an exponent is repeated multiplication, and multiplication times 4 is repeated addition. So what that tells us is that in general, if I have the logarithm base a of n to the r power, that is going to be r times the logarithm base a of n. So we're going to see that these are some rules that I'm going to need to use, some principles properties that I'm going to need to use when I start solving logarithmic equations. In our next lesson, we're going to practice using these properties. And what that does is it's training your brain to recognize equivalent statements. It's not going to seem like we're getting anywhere. We're going to look at one thing and then we're going to say this is equal to another thing, but we're not actually solving for any variables at that point. All we're doing is understanding equivalent statements, which we're going to use as we go through solving logarithmic equations. Before we do that, I want to do some examples here with some numbers in here to maybe kind of help you understand what these principles look like with numbers. So for instance, let's say that I have the logarithm base a of 3, the logarithm base 3 of 3. Because my base and my argument are exactly the same thing, I'm saying 3 to what power equals 3? That's equal to 1. You see if you can do this one. And I see that my logarithm base 3 of 1, I'm saying 3 to what power equals 1? And that's equal to 0. What about if I have the logarithm base 3 of 9? That's the same thing as the logarithm base 3 of 3 squared. So I'm saying 3 to what power equals 3 squared? Because the base and the base on the exponent are the same, that's just equal to my exponent. So if I have the logarithm base 3 of the square root of 3, remember from our lesson on how exponents work, the square root of 3 is the same thing as 3 to the 1/2 power. The base is the same, so this is equal to 1/2. Okay, let's look at these last 3 properties and see if we can convince ourselves that they really work and how they work. For instance, say if I have the logarithm base a of 8 times 2. According to our principle, that is telling me that this is the same thing as the logarithm base a of 8 plus the logarithm base a of 2. Excuse me, I don't need an a here, I need a 2. Logarithm base 2 of 8 times 2 is equal to the logarithm base 2 of 8 plus the logarithm base 2 of 2. So let's see if we can see how these two are exactly the same thing. If I look the logarithm base 2 of 8 times 2, that's the logarithm base 2 of 16. So I'm asking myself 2 to what power equals 16? 2 to the 4th power equals 16. On the right-hand side of the equation here, I'm thinking 2 to what power equals 8? 2 cubed equals 8, so that logarithm is equal to 3. And then 2 to what power equals 2? 2 to the 1st power equals 2, and 3 plus 1 is 4. So this is showing us why or how this logarithmic principle works. Let's try one with division. Suppose I have the logarithm base 3 of 81 divided by 3. according to my principle, I can break that up into two separate logarithms, logarithm base 3 of 81 minus logarithm base 3 of 3. Well, working down on the left-hand side here, if I do the division, 81 divided by 3 is 27. And 3 to what power equals 27? 3 cubed equals 27. If I work down on the right-hand side, 3 to what power equals 81? 3 to the 4th power equals 81. And 3 to what power equals 3? 3 to the 1st power equals 3. 4 minus 1 equals 3. So that's why those principles work. In our next lesson, we're going to practice using these principles to rewrite logarithmic statements. And we're going to starting with a single logarithm and then writing it as sums, differences, and products. And then in the lesson after that, we'll look at starting with sums, differences, and products and rewriting them as single logarithms. And these lessons are just practicing using the principles and training our brains to recognize equivalent statements so that when we get to the lesson on actually solving logarithmic equations, we'll